Let's continue with our probability. Probability. It's everything. Can you see on the screen? Okay. Probability. We'll continue from yesterday's question. Probability. Let's look at the following example. Let's get the following example. Trying to make sure that everything is covered. Sibongile polls 160 people. Sibongile polls 160 people to determine. Can you see on the screen? POLLS to deter. Thank God we're not doing English here. Determine if they like soft drinks, A or B. So it means maybe she was doing what she was questioning these people. And okay, stop. Her results. Her results are as follows. Her results are shown below. Shown in the Venn diagram below. In the Venn diagram. So sometimes the Venn diagram will be thrown for us. It's not always that we'll have to throw the Venn diagram in. So let's look at this Venn diagram. Just do this. Let's share and handshake. Thank you. Let's go. Okay. Date is closed. Let's say inclusion. 31. Then we're going to call this one A. We're going to call this one B. So this is 33. This is X. 65. Okay, there's our Venn diagram, and then we have 22 people who abstain. So let's read again. Sibongile polls 160 people. The total number of people is 160. Total number of people is 160. To determine if they like softball drinks, that is softball drinks A or B. So we have softball drink A and softball drink B. The results are shown in the Venn diagram below. From the Venn diagram, what can you tell us? How many people like soft drinks A only? That is 33. Those who like soft drinks A only, that is A only, they are 33, if you remember what you did yesterday. And then those who like soft drink B only, only, how many are they? 65. And then those who don't like any of these drinks, how many are they? 22. Do we know how many are those who like soft drink A and soft drink B? We don't know, since we put X there. That's very nice. So we must be able to read the Venn diagram. That's very good. Let's go to the question. The first question. How many people like both drinks A and B? How many people like both drinks A and B? Both drinks, they like both. How many people are here first? To answer this question, you need to check how many people are here first. So what you're looking for, we're looking for people who like both drinks. We're looking for these ones. Those who like both drinks, we're looking for these ones. So we're looking for X. That's what we're looking for. That's both drinks. It's X. So we're going to say X is equals to, what's the solution there? Solution Those who like both, I can say, okay, X is equals to how many people are in that were interviewed. It's 160. 160 minus those who don't like at all. They are 22. Oh, okay, let's subtract. Minus 33, those who like soft drink A. Minus 65, those who like soft drink B. Do you see that? So, what is the answer? How many are those who like both? How many? 40. Was it difficult? So from the Venn diagram, it's what we were getting here. We see that we have 33 people who like soft drink A only. Then we have 65 people who like soft drink B only. Then we have 22 people who don't like soft drink A or soft drink B. Then we have X number of people who like soft drink A and also soft drink B at the same time. So that's 40 people. So if we have 40 people who like soft drink A, who like soft drink A and B, it would mean that therefore, for those who like soft drink A, how many are there? It will be 33 plus 40. Those who like soft drink B will be 65 plus 40. Since these 40 people, they like both A and B. Is that okay? But at the moment, there is our answer. Let's move to number B. Determine the probability of randomly picking a person that likes. Let's write it down. Determine the probability of randomly picking a person that likes friends A or B. That likes friends A or B. Determine. So first thing first in this question, we need to check here. It's what is the question? The question is we're looking for the probability of what? Of someone who likes the probability of someone that likes friends A or B. It's either this person likes friends A or friends B. So it's what we call union. Do you remember what we did yesterday? A or B. So let's try. Let me hear from you. Maybe if you can remember. So we're going to say probability of A or B is equals to what? What do you think? Probability of what first? Let's start. Probability of what? Probability of A and then A only. Okay, it's fine. A only. And then yes plus probability of B. B what? Is it B or B only? B only. Are we done or should we add again? We must add for both. That's probability of A and B. Is that okay? Then we go back to our Venn diagram. We pick how many likes A only. Hello. Those who like A only, how many are they? Over what? 160. So let's go. It's 33 over 160 plus B only. 65 over what? 65 over what? 160 plus what? Plus what? For A and B, what did you get for A and B? Yes, it's this one, it's 40. This one, it's 40. So plus 40, plus 40 over what? 160. Then we add with our calculator, what we get? 69 over 80, and then you said in what instead form is 0.086 in decimal form. 0.86, so that's correct. You remember I said your probability cannot be equal to 1, it cannot be greater than 1. It must always be around 0 and 1. So whenever your answer is between 0 and 1, it means probably your answer is correct. Then let's move to the next question. Number C. Determine the probability of randomly picking a person that likes friend A and does not like friend B. Okay, so let's read the question. You need to understand the question first. Can you read for me? Can you read with understanding? Slowly. Yes. They said friend A. So let's read and so it means we are rejecting friend who? What are we rejecting? We're rejecting friend what? We are rejecting friend B. We are rejecting friend B, but we are looking for friend what? Friend A. So if I can go back and try to explain before we go to the answer. These 40 people, they like friend A and friend B. Is that correct? These 33 people, they like friend A only. So what are we looking for? We're looking for those who like, or we're looking for a probability of those who like friend A, but they don't like friend B. Is that correct? So it means we're going to reject this 40 because this one they like friend A and B, but we're looking for those who like friend A, friend A. They didn't say only. So it means those who like friend A, how many are they? They are 33. But to write down this statement, we're going to write it like this. Here is our answer. Did you understand how we are going to, what is that we're looking for? Or what is our answer? Okay, what do you think is going to be the answer? Just in roughly so. Numerator is going to be what? And denominator is going to be what? Roughly so. Our numerator will be what? And then our denominator will be what? Like numerator 33 is divided by what? 160. Yes, it is over or divided by 160 is the same thing. That's the same. Over or divided by 160 is the same thing, right? So that's correct. It's going to be 33 over 160. So I just wanted to know whether you have an idea what our answer would be. But this statement that they've written it here, mathematical or statistically, this is how we're going to write it down. Statistically, it's going to be this question like this: probability of A and not B. This is how we write not B. You see that that exponent one there or that at there? Yeah, it's to say not B. This for not B. So it only means that we are looking for what? For a probability of what? Of A only. We're not looking for B, which is equals to what? 33 over what? Over what? Over 160. Yes, what is the answer? What do you get? Decimally so 0, 0,01. 0, 0, 0,21. Thank you. Now let's go to our last question on this example. Then we go to our last example on this friend of ours on this problem. Then we will be done with probability. Then I believe that we'll need some previous papers and look at them. Is that okay? We need to look at previous question papers and look at them. The expectation after this kind of teaching is that in those previous question papers, you're going to do well. Okay, let's look at this question. Determine the probability of randomly picking a person that doesn't like brand A. Okay, can you read with some understanding slowly? Read. Okay. So if you get it straight and then you start to think about it, we are looking for someone who does not like brand A. So if there's brand A, this person won't be there. So let's go back to our Venn diagram. Can you pick the first number of people who don't like brand A? Those who don't like brand A, how many are they? 65 only. Is it 65 only? Look again. You don't like brand A. We don't care which brand you like, but you don't like brand A. Thank you. So 65 it is. They don't like brand A. 22, they don't like brand A. So that's correct. That's correct. So let's go. Number D. This is how I'm going to present this one. This statement. This one. Doesn't like brand A. So statistically, this is how it's written. Probability of not A. Probability of not A. This is how we present it statistically. Not A doesn't like brand A. Probability of not A is equals to what? Start with the 65 over 160 plus the 22 over 160. These are probabilities. What is our answer? 0.54. 0.54. That's correct. Example 2. Let's go example 2. Example 2. In a marketing in a marketing survey, 160 people were asked if they owned two different 160 people were asked if they owned two different brands of denim jeans. The choice was between Guess jeans and triangle jeans. Okay. The results of the survey are given below. So we have 85 people who owned, guessed. So we have 85 owned, guessed. So it means 85 people like 85 people like what guest jeans. 62 people owned 62 people owned what triangle jeans. And then 136 people owned at least one of the brands. And then the last point is that X people owned both jeans or both brands. Okay. So our focus, first of all, how many people are here? It's 160. We have 160 people. So that's our first focus. Then our next thing is that how many items are we talking about here? We're talking about 2 items, scarce genes and triangle genes. You see that? Then we go to our stats. Let's read here. We have 85 people who owned guest genes. If you read the statement, they're not saying 85 people owned guest genes only or guest genes only. They're not saying that. At the same time, they are not saying 62 people owned triangle genes only. They're saying 62 people owned what? Triangle genes. Then there's this statement which says 136 people owned at least one of the brand. So in total, what they're saying here is that in total, people who owned these genes, like Ntavi, are you here? With this statement, Ntavi, they're saying people who have genes, whether it's a triangle or a guest genes, how many are there in total? 136. Are you with me? So if we read this statement number 3, they're saying 136 people owned at least one of the brands. So what they're saying with this statement, in short or straightforwardly, so they are saying we have in total we have 136 people who owned gene, whether a gene is a guest gene or a triangle gene. But in total, how many are there? There are 136. How many people did we talk to? We spoke to 160 people. Of the 160 people, by 136 or about 136 ba ownang gene. It's either a triangle or a guest or both of them. But motho o na le gene by 136. So with this 136, it will tell us that there are people who don't have genes in this 160. Is that correct? We do have people who don't own these genes in these 160 people, because people who own genes, how many are they? They are 136. That's very nice. Then here they are saying the unknown number of people owned both. Unknown number of people owned both brands. It means we do have a what? An intersection between the two brands. So let's go to the first question. Record the above information in a Venn diagram. So to record this above information in a Venn diagram, step number 1, you need to check whether there is a what? An intersection between the two brands. There is. We have X people who own both brands. So what I'm going to do, let's go a solution, Venn diagram. Let's write the solution. Are you still here, Ntavi? Okay. There you are. Thank you. So there is our box, and then we need to indicate the sum of the sample space. How many people are here? 160. So this sum of the sample space, it's telling you that the numbers that are going to put inside here, all of them added together must add up to 160. Is that okay? Then there's an intersection between the two brands. So you're going to do your first circle and then your second circle. There it is. So there's an intersection, and then we have X people who own both. So this is for both. It's X. Then what are we dealing with? We are dealing with what? With guest genes and triangle genes. So I'm going to put G here for guest and then T for triangle genes. Then let's see now how many people owned 85 people owned guest genes. 85 people owned guest genes. It means we have 85 minus what? Minus X. Do you see that? We have 85 minus X. Why are we saying 85 minus X? Because we have X people who own guest genes and triangle genes. So we don't know out of these 85 people, how many owned a guest and triangle genes. So that's why we must subtract X. Then on this one, let's see how many own triangle genes. 62 people own triangle genes, but out of those 62, we believe that we still have those who own guest genes and triangle genes. So I'm going to subtract X here. 62 minus X. So let's try to 62 minus X. There it is. Thank you. 62 minus X. I can just try to do this. 62 minus X. Then this is your X. So does it make sense? Then remember, in this space, we must put the number of people who own triangle gene only. In this space, we must put the number of people who own guest genes only. But what we are given here is that we have a number of people who own both guest and triangle. And on the information provided, we're not told how many own guest genes only. We're only told that those who own guest genes, they are 85. Whether they own both, we don't know. Okay, but we have X number of people who own both. Then this statement 136, what are they saying? They're saying that the total number, the total numbers here on this triangle, on these circles. It's what or the total number of people who owned these genes. How many are they? They are 136 combined. Whether they own gas gene only, or both gas genes and triangle gene, or triangle gene only. How many are they? They are 136. How many people did we talk to? 160. It means then, out of this 160, we have a number of people who don't own gas genes and triangle genes who must put here. So what do we do to get that number? It's very easy. We say, okay, 160 minus what? Minus 136. What is the answer? 160 minus 136, what do you get? 24. So there are 24 people who don't own the gas genes and triangle genes. Then, Chavi, your Venn diagram is very correct. Is that okay? It's very correct. There's nothing wrong with it. You represent the information. I hope you have understood how to deal with such information and to present a Venn diagram. I hope you have understood. Now let's move to our second question. How many people? Let's write it down. How many people own guest, but not triangle. So we want to know how many people own what? Guest, but not triangles. If you listen to this question, we want to know how many people who own guest only. The number of people in this space. We want to know how many people own guest only in this space, except those who own guest and triangle. Let us say, how many people own guest but not triangle? It's very straightforward. It means we need to get the value of x. Straightforwardly, so it means we need to get the value of x. That's what we must do. So what we're going to do, we're going to, okay, to get the number of people on guests only, so we're going to say 84, 80, is it 84, 85, 85 minus x, which is this column, then which is this space, plus x, which is this one, plus 62 minus x is our solution. So to know the number of people who own guest only, we need first to solve for x. So plus x, which is 62 minus x, plus 24 is equal to the total, which is 160. So let's see, 85, let's add there, 85 plus 62 plus 24, what we get is 171. Then let's transpose 170 to the other side. Negative x is equal to 160 minus 171. Negative x is equal to negative 11. And then divide by negative both sides. X is equal to 11. So the value of x is 11, telling us the people who owned both gas genes and triangle genes, there are how many? There are 11. Then we want to find out how many people owned. What is the question? How many people own guest but not triangle? Then it becomes easy. Therefore, our final answer will be guest only is equals to 85 minus x. Our x is 11. How many owned guest only? 74. That's correct. Okay, now we can move. That was our first question, number B. Let's move to the next question, number C. We are almost there. This is our second last question. Number C, let's see. What is the probability that a person selected at random owns only one of the brands. And owns only one of the brands. So this person must own only one of the brands. Only one of the brands. So this person must not own both. You see that? So it means what we're looking for, we go back. We're looking for the probability of someone that own only this one. Remember here it's 74, né? Here it's 11, and then here it's 62 minus 11. 62 minus 11, it's 51. Okay, so we're looking for someone who only own one. So 74 people own guest only, 51 people own triangle only. Do you see that? So it means we're going to take these two, the probability of guest only, and then we add it to the probability of triangle only, because we're not looking for those who own triangle and guessed. We're looking for those who own only one of the brands. Very straightforward. Let's go. This is how we're going to answer this. We're going to say probability of only G, which is guessed, or only T, which is triangle. And that's equals to probability of only G plus probability of only T. Very straightforward, right? So how many are those who own only G? What is the probability? Yes, 70 what? 74 over. What is the total? Over 160 plus only T. How many? Let's go back. Only T. How many? No, it's this one. 50, 51. Yes, it's 51. 51 over what? 160. Then 0.78. There it is. Then our last question. So you need to compare the two questions. Let's look at number T. They look very similar, but they're not the same. Let's look at number T. What is the probability that a person selected at random owns one of the brand? Okay, can you read this statement? Do you see the statement only? Or do you see the word only? Do you see it? It's not there. So if you reread the question, you will hear that they are not referring to someone who owns only one brand, but they're saying who owns one of the brand. So you can be owning one or more. You can be owning one of the brand or both of the brand, because they didn't say only one. It means if you own one of the brand, even if you own both or more, you are still all right. Let's go here on this question. Can you hear me? Okay, so if we look here, we have 74 people who owns a guest only. We have 11 people who owns guest and triangle. We have 51 people who owns triangle only. And the question here is looking for the probability of people who owns one of the brand. It means you can own one or both. Therefore, the answer here will be very straightforward for number D. Probability of what? Of G or T, guest or triangle. Is that okay? Because you are owning one of the brand. So it's going to be probability of what? Of guest only, if you can put that way, guest only, plus probability of triangle only, that is T only, plus probability of what? Of owning both, because they said one of the brand, not only one of the brand, plus probability of what? Of guest and triangle. So if we look at guest only, that is 74 over 160, plus triangle only, that is 51 over 160, plus guest and triangle, that is 11 over 160. Then what we get? .85.